Alrighty, everybody. When we last met, I was working on 10 basic algebraic graphs. I was looking at the quadratic polynomial, the cubic polynomial, the graph of line y equals x, the absolute value function, the reciprocal of x squared, the graph of the square root, the graph of the cube root, the graph of the exponential function, the graph of the logarithmic function. Now, having successfully built those in Blender, I would like to go on to more beautiful math than even that. And to do that, I'm looking at Quora and cool graphs that this guy Devrat Hans has put up for us with the equations. So let's start with the heart curve or the cardioid, and let's grab this equation and let's make sure everything's working here in. Okay, I think it's working. So let's go here and let us create a new scene. And in that scene, let us add a cube. And let us make sure that we are viewing that cube from the top down so we can see the y-axis in green and the x-axis in red. And let's make a new shader node. And in this shader node, let us, the new shader node doesn't show anything. That's weird. It should show something in slot 1, but it doesn't. And that's probably, okay, so I'm going to put in a texture coordinate. There we go. And I'm going to put in a mapping node. Drop that in, connect the object to the vector. I'm going to add a separate XYZ. Drop that in, vector to vector. I'm going to add in a math node and set that to multiply. I'm going to add in a mix node, mix color actually, mix color node, and connect the value to the factor. And then I'm going to pick two colors that I like, red and green. There, I'm going to add a, what else am I going to add here? I'm going to add a BSDF shader, a diffuse BSDF. Is that the one? No, it's not the one that you usually add. I guess it doesn't matter. Maybe we don't even need that. I'm going to add a material output. All right, connect that in. And I'm going to connect these together to the value. And what you generally find when you do this setup like this is that you have one half of that cube being one color, the top color, and the other half being the other color, the bottom color. And you set the value really high to get it to be sharp. Otherwise, if the value is low, you'll get a nice blend. This is, after all, Blender. So I'm going to set that really high to make it sharp. It's good for graphing. And we're ready to start doing math. So having these shaders here, nodes, I will then add another math node. Now, since I have a math node, I don't need to keep going add and then try to find, like, where is my node. So, I mean, where would it be? I mean, shader would be there. Where would you find the math node anyway? It's light, there's Fresnel, there's targets. It's not there, it's not there, it's not there. There's a converter, so it's converters where math is. But you don't have to do that because you can just click on it and hit Shift D and make another one. I'm always going to be, from now on, using the quadratic formula, which is, and I'll type it in here, so let me add a text, and then let me go to the top view. Let me move my text over here and say scale it down, and then let me edit my text. And the way that it would work is, you know, it's actually, in this, I talked about it in my last video, it's 0 equals, and then you have a x squared, so caret 2 plus by plus c. That's the general form of the quadratics that you're going to be working with. And that's what you basically set up when you're doing this in your nodes. So after this separate x, y, z, you want to have at least 3 math nodes before you get to the multiply. So I'm going to add this one too, Shift D. All right, so those are the 3 values. And so that we know what they are, I'm going to go over here and pull this out. And for the label, I'm going to call this AX, and I'm going to call this one BY, and I'm going to call this one C. And if I really want to get specific about it so that you can tell that this is where I'm doing the math, then I probably want to change the colors of these and maybe make them, oh, I don't know, make them green. Do the same thing for this one. Make it green. And do the same for this one. Or I can have different colors. And I can, it's lovely. I mean, because color is a memory function. I mean, color helps with your memory. So maybe I go yellow, or maybe I go RGB. I mean, heck, why not even go like that? Like R is the X, and G is the green, and C is B, and then it's there. So now we know that's what I'm going to manipulate for most of the math. Now that I've got that set up, let me start with a power function, except I need to actually see what my equation is. And the real equation that I'm using, sorry about that, so let me go here and let me find Quora. That's what I want. That's what I'm going to copy. Let me bring this in. If you're confused by this, it's because I've already talked about this in the last tutorial, Blunder Through Blender, that I did. So I'm just riffing now, getting really fast with this stuff. You'd have to go back to the previous videos that I made, and they're on my YouTube channel, T. Culhane, to see what we're doing. Because I don't want to go through all that again. But this is going to be what I'm going to use. Oops, take that, scale it down. This is the equation that I want for the heart. I'm going to call this scene cardioid. And then I'm going to start working on this. So there's an x squared here, and the x in separate xyz is plugged in here. So this is a power function. And then the a part of it, the exponent, is what's here. Oh no, sorry about that. No. So this is not ax. I have to repeat this. All right, we need a few more of these, but I'll keep it red because it's dealing with the x. One is power. Power comes first, then comes multiplication by a value. So the exponent here is 2 for x squared, and then it has an a value, but the a value is 1 because there is no value number in front of this, right? So we got that. Now, for this part here, we're going to do a separate thing. We're going to take this down and bring y into this. And I'm going to make that a power function. So power. Y is going to go to 2. And just as I need to change the label for this, this is not ax, this is x squared. So do your labeling so you don't get confused later on. This is going to be y squared. All right. So the y squared also needs to be strictly in this quadratic formula. I need to have a multiply function for it. Change this name to by, and then I'm going to keep this at multiply, but the value is going to be 1 because there's nothing in front of this. Now, everything happening in parentheses has to be done first, and now we can go sort of sequentially through. So we say this is x squared times 1, fine. You have to add that. So let me add a math node here and say to it, I want to add this and this together. Break this for now. All right, so I'm adding x squared plus y squared, and then I need to put in a minus ax. So I will set up above this another math node, to which I will plug in x. And it's going to be a multiply node for x. And it's going to be set to 1. Because right now we don't have anything on there. So multiply, and then that ax is going to be subtracted from these two. So we're going to plug that and that, move this out of the way. Let me put in another math node. Seems complicated, doesn't it? And yet I really understand it now, so I'm not freaking out like I was the first time I watched a YouTube video about simple ways to do this. Now I'm in uncharted territory because I'm trying my own thing. But this value here, which is ax, is going to be subtracted from this value, which is x squared plus y squared. So if I take this value and put it in the top and put this value in the bottom, then I'm subtracting ax, because that's what this is. I want to identify that. That's ax. And the reason that that's ax is because I've taken the x value, as you can see, and plugged it in, and then for the a, multiplied it by 1. So that's ax there. And then that whole thing has to be squared, like all of this, because now I've subtracted the ax from this part here, and then that parenthetical has to be squared. So I'm going to add another math node and make it a power, and make it, first put this value in there, and the exponent is now 2. So that takes care of this part of the equation. However, we've got to rewrite this. Haha. So to rewrite this, let me copy it and bring it under and go to edit. And I've got to move all of this and subtract it over there, and then say equals 0. So, right, so if I subtract that from both sides, since that's multiplied, that should work. And then that means that when I get to my equation in the nodes, I now have to take this power, which if I want to be able to remember where I am, I should label it as, in fact, I'll just copy this if I can. If I go into edit, I should be able to take that. I should be able to come in here and place that. Yeah, there we go. So now I know where I am in this equation, and then I need to do the same thing for this. Oh, lordy. Okay, so let me move this down. It's the same y input, but I need to create a math node for, let me take this one here, bring it down here. This is going to be, oh, you know what I can do? These are so similar. Now I'll do it. I'm not going to try to be more fancy. I have to take this, and it's got to be a squared 2. Sorry, it's just a squared. That's interesting. A squared. So a squared is a power relationship where, but there's no y there. It's just a. How do I get a? It's going to be 1. So the base, the exponent is 2. The base is 1. The base has to change. Ooh, okay, now we're getting into something I've never worked with before. Because I need to be able to vary what a is. Oh, wait, 1 squared is 1. So in effect, for now, it's not even going to matter because I'm just going to put the base as being 1. And then I'll figure out later how to do this. Because then I want to go into this parenthetical is, wherever this is, I'm just going to call this a squared. I don't get into trouble with all this. Now I need an x squared plus y squared. So if I make another node here, and I call this x squared. Yeah, I'm recording. No, not with students. Thanks. Oh. Oh, I did. I just finished meeting with them. Okay, now x squared over here means I take the x value and plug it in to the base. The exponent is 2. So, okay, so we have another x squared there plus y squared. So I need to make a y squared and plug y into the base for that. And the exponent is 2, and I'll call this y squared. And then I want to add them together, so I'm going to put in the add node where I add this value and this value, and I call that x squared plus y squared. That takes care of that. That gets multiplied by this. So I'll add a multiply node and multiply the a squared by, which is 1 in this case, by that, and then that has to be subtracted from this. So lordy lordy. So then this, which is x squared there, so that then, so when we've multiplied this, what that should look like is, that's, let me go in and grab that so I know what it is, I don't lose it. So whoops, grab this, go to edit mode, make this, it's not that, make this that, and come in and rename this so that I know that that part has to be subtracted from this part. So what is this one here? That's C, and C is irrelevant in here, but I'm going to keep it in there anyway because I want to stay within the quadratic formula if I never needed to change anything. Oh, and look at there, there's the actual output from there. The SDF shader and that output there, okay. So with this, at the end of the chain, this, what I'm saying is that minus that. So I'm going to take a math node, this will be my final math node of this whole fancy equation, and I will make it a subtract, and I will take this value, x squared plus y squared minus ax, everything squared, and I will put that into the top value, and I'll take the a squared times x squared plus y squared and bring that into here. So that is being subtracted from that, and that equals 0. So then we'll put that in with the value of C, which is going to be 0. So this is not an add. This is supposed to be a, oh yeah, it is an add, plus C. But this value is going to be 0. Aha! And we've got our cardioid. How cool is that? But you're not seeing it because it's not mapped right. So I've got to change my scale. And if I change my scale from 2 to, then you get the cardioid. Ain't that fun? Look at that. That is, in fact, what we saw. Let me save this. That cardioid is what we saw here. And it's at that same point. So that's a beautiful equation there. And if you do change C, which we gave no value to, then you're changing the y, the y-intercept. Oh my gosh. No, that really messes things up, doesn't it? So much for C. All right, so there's the cardioid. Notice it is coming around the y-axis and centering on the x-axis in there, just as it shows here, right? That's probably at 20 there because that's the equation that we've put in. So if you were to count, you'd probably get, maybe not getting 20, I'm not sure. But depends on how the units are calculated. Now, in this very first thing, I said I could manipulate the A in front of the X, but I choose to leave it at 1. The other thing that we could manipulate in here, can't manipulate the exponent because we're doing squaring. Can't manipulate those exponents there. The base here could be manipulated. That's that A squared. And whatever we want to square it, it certainly changes the cardioid. And I guess in this function, you can manipulate the value of A. There's also an A in AX. And where's my AX? There it is. So I could change that value. Now that one really does something. That's the value of A in AX, but they're not tied together. And what really we should do is set up some kind of an index to bring in these variables. And I'm not sure how to do that. It'd be input, UV map texture coordinate. We already have a value. Maybe it's value. Let me see something. What if I put in input value? But can I make it more than one value? Like, can I, under properties, node, tool, options, item. So there is a way to, I mean, I could make this A if I wanted to. I could label this A, or say A value, so I know it's a value node. And I could plug this in instead of having the AX have a value that's calculated here. I could take this A and pop it in there. And then when you put this to 1, it makes the cardioid. And since I have that A value, I can also put that in my equation where I have the AX squared, which is here, and have that value be the base. And it does exactly the same thing. But then when I change the value of A, then I start getting interesting results. So that is my A value. And I can then add B values and C values. In fact, this value here that has C that we're subtracting, it should have a value that's controlled by another value. So if I go Shift D, take this, and this I call C value, then I have a place for that, and I can move that value of C into where C is. But of course, it's supposed to be 0 for this equation. But at least I have that, and I implies that, what's the matter, buddy? Well, things get broken. I'll make this b value for my quadratics, and then that's not going anywhere because there is no b in this. Nye? I'm in the middle of recording, sweetheart, so I can't help you. All right, you know what we're gonna have to do? I'm gonna have to stop, and we'll get back to the other equations that we're making here. All right, so I'm gonna stop now and come back to you. Bye-bye for now. All right, sweetie.